In 2.6, we'll look at a couple different ways where we can, or several different ways where we can combine functions. But we'll also be looking at the domain of those functions. We talked about domain a little bit in chapter 1, but this domain is the set of all x values that work in the function. Many times a domain is negative infinity to positive infinity, or all real numbers. But we need to watch out when we have fractions or square roots, because that's where you get domains that are not all real numbers or negative infinity to positive infinity. So first of all, we'll talk about fractions. We can't have 0 in the denominator of fractions. You have to remember that because that affects the domain. So you find out what number gives you 0 in the denominator, and then you exclude them from the domain. And we'll look at some examples in a minute. The domain is square roots. This is the other place where you have to be careful, is square roots. You can't have a negative number inside the square root. So you make the inside of the square root greater than or equal to 0, and then you solve for x, and that's the domain. So let's look at some examples of this. So in this problem, we've got a fraction, and so we have to worry about the denominator of the fraction. So we have x squared minus 4x minus 5, and we have to find out what gives us problems. So we'll see where that equals 0. So this we can factor. Two things that multiply together to give us negative 5 and add together to give us negative 4. So that would be negative 1 and, oh, let me go with the other direction. How about negative 5 and positive 1? Because that will add to give me the negative 4 that I need. So when I factor it, I would get x plus 1 and x minus 5 equals 0. So I split that apart into two pieces. X plus 1 equals 0, x minus 5 equals 0. Now subtract 1 from both sides. X equals negative 1. And then over here I'll add 5 to both sides. And x equals 5. So now let's talk about what we do with that, because remember we're finding domain, it's not that we're solving for it. So if we think about this as being on a number line, negative 1 and positive 5, what we're really saying is that these two numbers gives us problems. We can't have negative 1 and we can't have 5 because that would give us 0 in the denominator. So we want the numbers that are to the left of negative 1. We want the numbers that are between those, and we want the numbers that are bigger than 5. So we need to write that in interval notation. So again, we would read from left to right. We would have negative infinity to negative 1. We can't use negative 1, so we'll use a parenthesis. And then our next piece would be between negative 1 and 5. We can't use negative 1 or negative 5, so we'd have parentheses. Put a u right there, and then another u, and then our last piece would start at 5 and go to infinity. And that's the domain for this function. It's all real numbers except for negative 1 and 5. So we want to include everything except for those two numbers that gives this problem, this equation problems. So in this problem, we've got a square root. So square roots have a different set of issues. The inside of a square root, 2x minus 5, can't be negative. So that means it has to be greater than or equal to 0. So we'll add 5 to both sides. And that gives us 2x is greater than or equal to 5. And divide both sides by 2. And x is greater than or equal to 5/2. So let's look at that on a number line. We just mark the 5/2. And we want to be bigger than that, so we would go this direction. And it says greater than or equal to, so we'd have a bracket at 5/2. So now we can write that in interval notation. We'd have bracket 5/2 to infinity. And that would be our domain. So if we look at this problem, it says find the domain of 4x minus 5. Well, here there's no fractions and there's no square root, so there's nothing that messes this problem up. So the domain is just negative infinity to positive infinity. All real numbers. This problem has a fraction, so that means again we take the denominator and we set it equal to 0 to find out what messes things up. So we'll start by subtracting 2 from each side. And then we'll divide both sides by 3. And we get x equals negative 2/3. So we'll look at that on a number line. This tells us that this negative 2/3 would give us 0 in the bottom of that fraction, so we want to cross that number out of our possibilities. That means we're okay with everything to the left of it and everything to the right of it, just not that number. So we'd write negative infinity to negative 2/3. We can't use that number, so we use a parenthesis. And then on the other side, we would have negative 2/3, again with a parenthesis because we're not using that number, to infinity. And that's the answer to that domain. So here's another problem. It's got a square root in it. So again, with the square root, we look at what's inside, and we make it be greater than or equal to 0. So I'll add 1 to both sides. And then I could divide both sides by 4. So we get x is greater than or equal to 1/4. So if we look at our number line, we have 1/4 marked on it. We want greater than, so that would be this direction. Equal to, so we'd have a bracket. So that tells us how to write our interval notation. We'd have a bracket, 1/4, and then it goes on for infinity. We can combine functions in several ways. We can add, we can subtract, we can multiply, or we can divide. There's one other way we'll talk about in a little bit. When we find the domain, we have to determine the domain before we simplify. So let's look at this. This tells us to find f divided by g. So f we see is right here. That's going to be on top. X squared minus 4. G, and C, that's going to be on the bottom, so x minus 2. So for finding the domain here, we have to look at this denominator before we do any simplification. We have to see that x minus 2 can't equal 0, so we're going to look at what makes it be 0. We'll add 2 to both sides, and that gives us x equals 2. So on our number line, we're crossing out 2, that's what's giving us problems, with the denominator of the fraction, which means that we can go everything to the left and everything to the right. So our domain here is negative infinity to 2, and then 2 to infinity, with a union between. Now let's go back to this f divided by g, because we can do some simplifying. The top of this fraction actually factors to x plus 2, x minus 2. In the denominator, we have x minus 2. So that cancels out, and we'll end up with x plus 2 is our answer, with this as the domain. And that's just really trying to make the point that we have to do the domain before you do any simplifying. Okay, so this wants us to find f plus g. So f is right here. We'd have square root of x plus 3. And put the plus sign between it. And then g is right here, which would be x minus 2. Now that we actually can't simplify, so that's our answer right there for f of x plus g of x. But now we need to find the domain. So we have to find the domain in two pieces. There's this piece right here, it's underneath the square root, so we have to say x plus 3 has to be greater than or equal to 0. We can subtract 3 from both sides. And it tells us that x has to be greater than or equal to negative 3. And then when we do this one, it'd be x minus 2 is greater than or equal to 0. Add 2 to both sides. We get x is greater than or equal to 2. So if you think about that on a number line, we'd have negative 3 here and 2 here. The green is telling us that we would have a bracket here and then going to the right. But the purple part is telling us we would have a bracket here and then going to the right. So the domain for this problem is only where those two graphs overlap, only where we have both green and purple, which would be right here. So we would just write for our domain 2 to infinity. So this means right here that we're really doing, it really wants us to do f of x plus g of x. So f of x is 5x plus 1, and g of x is x squared minus 2x plus 1. And put a plus sign between them because that's what's here. And then we would look for any domain, for the domain before we simplify. Notice there's no fractions and there's no square root, so that means the domain is negative infinity to positive infinity. Now we'd simplify. Because of the plus sign here, there's nothing in front of these parentheses. That means those parentheses aren't doing anything. So we can just drop the parentheses and then combine like terms. So here I have a 5x and a minus 2x. Here I have a plus 1 and a plus 1. So I'll start with x squared because it's my biggest exponent. And then I do the 5x minus 2x, so that's plus 3x. And the plus 1 and plus 1 would be plus 2. So this is my answer. So if we look at part B, this is really saying I want to do f of x minus g of x. So f of x is here, so I'd have 5x minus 1 minus, then g of x is here, x squared minus 2x plus 1. Again, start with the domain before we simplify. There's no fractions, there's no square roots, so the domain is positive or negative infinity to positive infinity. Then we want to simplify, so that means with this minus sign that's in front of those parentheses has to get multiplied through. Now these first parentheses aren't doing anything. We can just write 5x minus 1 because there's nothing in front of them. So here we'd have negative times x squared is negative x squared. Negative times negative 2x is positive 2x. And negative times positive 1 is negative 1. And then again we want to combine like terms. So I'd have these two that I want to put together and these two that I want to put together. So I'll start with my x squared, negative x squared. 5x plus 2x is 7x. And negative 1 minus 1 is negative 2. So this one means that we want to do f of x times g of x. So if I look at f of x first, that'd be 5x minus 1. G of x would be x squared minus 2x plus 1. We'll start by looking at the domain before we simplify. There's no fractions and there's no square roots, so it would just be negative infinity to positive infinity. And then we need to multiply this to simplify. So to do that, we start with 5x times x squared. It gives us 5x to the third. And then 5x times a negative 2x is negative 10x. And then 5x times a positive 1 is a positive 5x. I made a little bit of a mistake here though. 5x times a negative 2x is 10x squared, negative 10x squared. So then we want to do the same thing with this negative 1. So we'll take negative 1 times x squared, would be negative 1x squared. And then negative 1 times negative 2x will be positive 2x. And then negative 1 times positive 1 would be negative 1. And then we want to combine like terms. So this 5x cubed, there's no other thing, and nothing else that has an x cubed on it. So we'll just write that. But then there's a 10x squared and a 1x squared, both minus. Minus 10x squared minus 1x squared is minus 11x squared. And then plus 5x plus 2x is plus 7x. And then minus 1 on the end. So this is our final answer. This problem wants us to do f of x divided by g of x. So f of x is going to go on top. G of x will go on the bottom. And then we need to look at the domain. So for the domain, remember, we need to look at the denominator of the fraction because we have a fraction. We need to set it equal to 0 to find out how it messes up. We can factor this. We want two things that multiply together to get 1 and add together to get negative 2. And that'd be negative 1 and negative 1. Okay, so we'd have x minus 1 and x minus 1 equals 0. Set those equal to 0 separately. So that gives us x is equal to 1 and x is equal to 1. So again, on our number line, that means really that we're crossing off 1 from the problem. We can use everything to the left and everything to the right. So that tells us that our domain would be negative infinity to 1 and then 1 to infinity. So with this problem though, there's no way to simplify it because even with the denominator factored, which we did over here already, there's nothing that crosses out. So that means this or this would be your final answer, along with this domain. So now this says take f of x minus g of x and find the domain. So here I have x minus 1, and I want to subtract square root of x minus 6. We have to find the domain, so we're going to look at this x minus 1 piece. So we take x minus 1 greater than or equal to 0. We add 1 to both sides, gives us x has to be greater than or equal to 1. We'll look at the x minus 6, greater than or equal to 0. Add 6 to both sides. That gives us x is greater than or equal to 6. So if we look at our number line, we'd have 1 here and 6 here. This green piece would say that we have 1 included in a line going to the right for greater than 1. The purple piece would include 6 with a line going to the right. And again, remember that we care about where both happens, both the green and the purple. So that'd be this part over here, which tells us that our domain is really 6 to infinity. Now this square root part cannot be simplified, so that's just done. You can't combine square roots when they don't match. We'll stop there with this video and finish up the last part in another video.